5x plus 1 over x squared minus 1 is greater than 2. Again, we want to swing this up, but we can't just swing it up without taking into account whether it's positive or negative. We know that when x squared is when x squared is greater than 1, this denominator will be positive. So that means x needs to be greater than 1, or x needs to be less than minus 1, doesn't it? Both of those, when squared, will give a number bigger than 1. So in this section of the real number line, we'll look at this inequality now for this section of the real number line. So here, this is positive, so we can simply move it up. 5x plus 1 is greater than 2 brackets x squared minus 1 then. So 5x plus 1 is greater than 2x squared minus 2, just expanding the bracket there and there. So read from right to left, the 2x squared, move the 5x over to be with it, to be minus 5x. Then also move the 1 over to be minus 1, to be with the minus 2 to make minus 3. Reading from right to left, that means that this is less than 0. Factorise now, hopefully it will. So it'll be 3 ones, won't it? And then we've got minus and plus is less than 0. So let's just check that. 2x squared minus 6 plus 1 is minus 5. Plus times a minus is a minus. 1 times 3 is 3. So this is less than 0. It's a quadratic with roots 3 and 3. When x is 3, that's 0. When x is minus a half. And this quadratic is positive, so it's a U-shaped curve. Like so. And when is this underneath the axis? It's underneath the axis up to, but not touching 3, and down to, but not touching minus a half. Okay, so this is, we considered this line segment, and we solved this problem for this line segment here in this context, and we ended up with this inequality. So we need to see what the overlap is between the context of the problem and the solution set to see if there is an overlap. Well, we can see that when x is bigger than 1, that's fine, and up to 3. So here then, we've got x is bigger than 1, of course, because that's the solution set we're considering in this context, but it can only go up to 3. And on the other side, when x is greater than minus a half, well, there's no solutions for that, is there? This part of the problem we don't need to worry about that, because we've already said that x is less than minus 1. So it's only from 1 up to 3. So that's that part of the problem done then. Now let's look at the other side, and now we'll look at when x in the other segment that we haven't considered. We don't want when x is 1 because the denominator will be 0. So we just look at now when x squared is less than 1. So that happens when x is less than 1, between 1 and minus 1, isn't it? Smaller than 1 in terms of its magnitude, and the denominator will be negative then, won't it? It's the opposite to this section here. So the whole number line is now being considered in these two cases, except for the actual points of 1 and minus 1, when the denominator is 0. So let's look at this case. In this case, the denominator is negative. So when we move it up, it will flip the inequality around. So this will be reversed. So we get 5x plus 1 then will be, instead of greater than, it will be less than 2. And we can just write what we had down before, 2x squared minus 2. Now move the 5x over, we get 2x squared minus 5x. And then move the 1 over minus 3, same as before, but this time it's greater than 0. The same factors apply. Factorization is the same. 2x plus 1x minus 3 is greater than 0. That's a U-shaped quadratic, as we've said above here. When is it greater than 0? It's greater than 0 when x is bigger than 3, or when x is, that's bigger than, less than minus a half. So if we look at our context of this solution set here, the bigger than 3 doesn't overlap at all, does it, with this segment? But this does. When x is less than a half, that lies inside this range. So we have the solution set here, minus 1 x can go down to -1, but it can only go up to -1/2. So there's our solution set. So finally then, consequently, let's just pull the two subparts of the problem together then. Consequently, x can lie between 1 and 3, and x can lie between -1 and -1/2.